certainly want to make sure that you've got this on your note card. You won't see tons of compound interest problems, but you'll see one at least. For compound interest, the P right here stands for your principal. This is not Miss Burton. This is what we call the amount that you begin with. That's called your principal. Did I spell it right? Is it P-A-L for principal, or is it L-E? Let's see. I think principal with the L-E is like your like you have principles about you, your fundamental truths. Yeah. Yeah, it's AL for this. So it's spelled the same as like Miss Burton, the principal. But it means the amount. You could call it your initial amount here. R is still your rate as a decimal. N is going to be the number of times that you are compounding the interest per year. Okay, that's going to be the difference because everything else we've looked at so far, we've only been compounding one time per year, or per hour, or whatever the rate. It matched the rate there. T is the amount of time. A would be your total amount that you've got there. Let's look at an example. So Laura deposited $12,000 into an account that earns 8% interest. How much money will she have in 5 years if the interest is compounded quarterly? Okay. So unless they tell you otherwise, if they give you an interest rate, assume that that is your annual interest rate. That's how banks report interest rates. They tell you the annual interest rate. So unless they tell you otherwise, unless they tell you that you're getting 8% per hour or something, assume that that's the yearly interest rate. So if we're using this formula, we will have A equals our principal, or our starting amount is $12,000. And then we're going to do 1 plus our rate as a decimal, which is 0.08, divided by number of times compounded per year. So if my interest is compounded quarterly, how many times per year is that going to be? 4 times. 4 quarters in a dollar, 4 times per year. And then you will raise it to the N times T power. So it's going to be, the N is 4. Whatever number goes here also has to go up here. It's easy to forget to use that, put that number there. And then we'll multiply that by 5. It's really the same thing. I'm going to show you here in a second. I'm going to compare something for you. I need a Desmos. Pull this up here. Okay, so we'll have 1,200. The good news about this is you can type this whole thing into Desmos like it is. You don't have to actually like calculate anything. Desmos can do it. Make sure you're doing 2 to the 4th. Let's see, there we go, 2 to the 4th times, I think I need parentheses. Yeah, you're right. It jumps down if we don't put parentheses right there. All right, so we would have $17,831.37. So 17,000, what was it? 831.37. What is unrealistic about this is you're not going to get 8% interest on a savings account. So savings, my best savings account is like a money market savings account, and it gets 2% interest. My other savings account gets like 0.5% interest. It's not very good. There have been times in history where savings accounts could get maybe not 8, but like 4 or 5%, but not right now. And they're higher right now really than they were like 5 years ago. So 8% interest, you're going to have your money in something that's a little more high risk, like stock market stuff, and that's higher risk because put money in the stock market, you can earn more money, but you can also lose the money. If you put something in a savings account, you're not going to lose any money. You're just not going to make money as quickly that way. So, now let's think about this. What if it was just compounded annually? Let's just compare it. Okay, this is not part of the problem, but let's just compare it. If we were just compounding annually, it's really the formula we've already been using, right? The a times b to the x. Because if we use compound interest, we could use that. We'd have 12,000, and we do 1 plus 0.08. And if I'm just compounding annually, how many times per year is that? It's just 1. Annually, it's just 1 time. So it would just be a 1 right there, and then I do 1 times 5. Well, if you think about that, that really is just 12,000 times 1.08 to the 5th power. It's the same as doing what we were doing on those easier problems, right? So if it's compounded annually, you don't necessarily have to use this formula. You could, and it will still give you the right answer. Let's see what number we get for that, just out of curiosity. Um, 17,631.97. So it's not going to make a huge difference. How often you compound your money doesn't make a huge difference. But the more frequently you compound your money, the better it's going to be. So if you have an option between annually and quarterly, you want to go quarterly. Because you can see, now this is over 5 years, so and it's a pretty high interest rate. But it made $200 difference. You wouldn't ever be like, no thanks, I don't need that $200. You can keep it there. So, so the more often that your money is compounded, the better that is. It doesn't make huge differences, but it makes a difference. I don't like the next problem because loans don't quite work this way. And I should go, they do work this way, but you also have to be paying on the loan. They don't just let you take out a loan and then don't pay it back. So I might skip that one, actually. I need to take that one off of there. Let's skip that one. All right, this one is a realistic problem. 0.8% on your savings account. This is realistic. You can get 0.8% on your savings account. So Bob is depositing $300 into this account. Interest is compounded bi-monthly. Oh gosh, now you're making me question myself here. I think it's 24. Bi-monthly is 2 times a month. What do you call every other month? It would be something similar, though. Let's just give this to Google to make sure I am right about it. Oh, it's every other month. Oh, gosh. What do you say? Oh, okay. Semi-monthly means twice a month. So Daisy was right. Bi-monthly means every 2 months. Oh gosh, let's write that down. Yeah. Yeah. Let's write those 2 things down just so we don't forget them, because that seems like an easy one to forget, clearly, because I've forgotten. So bi-monthly is every 2 months. So for that, your N is going to equal 6. It's going to be 6 times per year. Same as every 2 months. All right. Semi-monthly. Semi-monthly would be twice per month. I don't either. And so that would be 24. There's a good chance if I put one of these on your test, I will put in parentheses every 2 months or parentheses twice per month there so that you know what it is. Okay, so we are doing bi-monthly, so we don't really need that semi-monthly. I'm just writing it down so we remember that that is a thing and those are different. Yeah, every 2 months. All right, so we're going to do 1 plus rate as a decimal. What's that rate as a decimal? 0.008. You still have to move the decimal even though it looks like it's already a decimal. All right, still got to move that decimal 2 places. 0.008, and we're going to be dividing it by 6 to the 6 times 10. All right, so if we put that into Desmos for us here, we are going to get 300 times 1 plus 0.008 divided by 6 to the 6 times 10. And so we've got $324.97. Yeah, you're not making much money, right, off of that. It would be a good idea to find a better investment plan for that. Savings accounts are a good place to keep your money that you might need soon. If it is money that you are like saving up for longer term, it might be good to try to find something that is higher interest. But with higher interest comes higher risk. So mutual fund, we have some of our money in like mutual funds. They're stock market, so you can still lose money on them. But it's like instead of buying Apple stock or you know Ford stock or something like that, mutual funds are like a bunch of different stocks together. So if you like, maybe it includes Apple, and Apple does badly this month or at this time, but it includes Ford also, and Ford does well. It kind of balances out, so it follows the market instead of just the volatility of one single company. My husband, he takes some of his money he makes playing music, and he will sometimes put it in the stock market, and he invests like he's a middle schooler, and he just buys stock of companies that he likes. So for a while he had some Apple, he had some Tesla, and it was not working out great for him. He's mostly taking everything out of that now. He was losing money, and he was like panicking every time he'd lose money. Then he'd sell it, and then as soon as he'd sell it, it'd shoot back up. Yeah, it's a wild ride.
I learned more in this class about real world stuff than I have in the last, 13 years.
Yeah, it's good. I wish we could teach a class that was just that stuff, because I can't promise that you're going to be finding the inverse of a log equation in your real life. But yeah.
We're literally doing like a shrimp thing. A shrimp? I have missed 2 days.
Well, that econ class, they do. They teach it to you in 7th grade is when all of your like percentages and things like that happen. And in 7th grade, it doesn't mean much to you, like, because you don't have a job, you don't have cars, you're not very close to actually having to do any of those things. Plus, some people are just like not ready for it. It's too early to really introduce that, in my opinion. Like to some kids, like you need a stronger foundation in the basics. But But the econ class is an attempt to teach some of those things, and I do think Mr. Blevins does some good things with it. And I taught Mr. Blevins because I'm old, and he was a very good math student. So I think it's probably a lot worse at a lot of other schools because putting that in the history department seems crazy.
By any means, but I feel we learn more real
Yeah.
like real world stuff in these things because it's mostly so far just been studying like things that have happened in the past that have nothing to do
Right.
with current time.
Help us in the future.
I think more will come along in that class where it'll be a little more helpful.
The economics part and we actually go to the personal finance.
Yeah, I think you'll probably see more there. I think it'll get better. I think. Yeah. But yeah, it would be a good idea because these are good things to know. All right, this question is only slightly different. So we're going to invest $750.
Why did you go Y?
I could use an A, mostly because I'm going to have to put this one in Desmos, and Desmos is not going to like an A. And I know that because I'm thinking ahead here.
Why either?
It's okay with Y's. It can do Y. So, yeah. So, 3% is 0.03. All right, compounded weekly, 52 times per year,
How'd you get that?
because there's 52 weeks in a year. Hannah's looking at Daisy like she's a genius. So 52 weeks in a year, maybe something good to add to your note card. If maybe you are surprised that there are 52 weeks in a year. Because I am certain that one of the questions in the question bank has weekly on it. So I'm not sure if I put bi-monthly there or not, but I'm pretty sure I put weekly on at least one of them. So I put that on my note card, especially if you didn't know it. And so we'll have 52 right here. And now I've got 1,000, but does 1,000 go right here? 1,000 is the amount of money, not the time. So I'm going to put an X right here for right now, or you could use a T if you want, but because I'm going to type this into Desmos, I'm not going to do that. So I could set this up and solve it by hand. You guys do have the skills that would be necessary for that. It's not the easiest because you've got a lot of stuff going on there. So let's just go with Desmos on this one. So, yeah. So f of x equals 1,000. G of x equals, or you could use y's for both of these. That would work as well. 750 times 1 plus 0.03 divided by 52 to the 52x there. And right now I see nothing. Okay, because I know this goes up. I know need to at least go to 1,000, right? So you can zoom out, but it gets really distorted if you zoom out because like it will work and you can find it. What I would suggest, because these aren't the biggest numbers, we're going to have numbers that are bigger. If you hit the wrench right here, you know your y needs to go up to at least 1,000. So just change the y and then zoom out from there and you'll get a better picture that's not just like so condensed right there. And so we've got 9.592. Years. Yeah, X in this case is your number of years. So what the formula is doing is like our rate is weekly, so that's adjusting it to weeks instead of years. But as far as the answer goes, it's going to be years. Uh-huh.
You're so funny.
Yes, yeah. If you replace that back in there, then you would get $1,000 or pretty close to it. We rounded a little for it. All right, one little last thing. Okay, so if you were old like me, the Pert shampoo would have came out whenever you were a small child, and there'd be a lot of commercials on TV about Pert shampoo. Is the amazing invention of shampoo and conditioner in one, which doesn't work all that well. It is always amazing to me how they market to men and market to women so differently. Because if you go down like the men's aisle, there are a ton of 2-in-1, 3-in-1 shampoos. It's like shampoo, body wash, conditioner all together. They tell you it's like everything.
They don't have to
Yeah.
Motor oil.
Yeah, like you can use this for anything you want.
Because men don't have to try it. All
They got one bottle. They just wash everything with it. On the other hand, women, you need shampoo, you need conditioner. Perhaps we'll sell you this hair mask, this leave-in conditioner. Like they're trying to get you to buy every product, obviously because we will, because they wouldn't do that if we didn't. So,
men literally all they have to do is just jump in the shower, get out of the shower, you look good.
All right, we gotta finish this. What's happened? Okay, so this is for compounded continuously. So if you see that something is compounded continuously, so it could be, compounded quarterly, monthly, weekly, daily, like it's going to get better and better. So the most often it could be compounded would be continuously. And I don't have time to go through to show you like where this E right here comes from and how that is, but this is the formula you use if you get to continuously. And in this formula, A is your final amount, P is your initial amount or your principal, R is your rate as a decimal, not a percent. You don't add 1 to it or subtract it from 1, it's just the rate, and T is the time in years. And we've talked about E as a number. So let's just do one of these. Adam invests $1,051 in a savings account with a fixed annual interest rate of 6%. That is compounded continuously. After 8 years, what will the account balance be? So if you see compounded continuously, that means you're using P-E to the R-T. So our principal here would be 1,051. E is a number. You leave it there. It's not a variable. So it's going to be E to the, we need the rate as a decimal, so 0.06, and the time, which is 8, right here. And so you would just plug that into Desmos. I believe it is a child. And the bus is not here yet, so I don't know what this child is doing. All right, so we would get 1,698.49. For our answer there. So, if you see that phrase compounded continuously, you need to use the PERT formula. It's really not difficult to use. It's as easy as any of them really to use there. Yeah. So it's actually probably the easiest one, really. Yeah. You definitely could solve these by hand, like if you. Well, I mean, this you just type it in, but like on number 6, which we're not gonna have time to get to, you could solve it by hand if you want, or you could just graph it. Yeah, you would have to log it. Yeah.
Yeah, just take a log and throw